All right. The plan today is we are just going to be talking about solving rational equations. There's no new ideas going on here. We're just going to be talking I got 4 examples to run through, and that's the gist of it. Okay, homies? We're just talking about solving. So if I have an equation that involves a rational expression like 3 over x, the technique that I recommend using, there are several, but I'm only going to teach you one because I think on average it's the easiest to deal with, and it is extremely versatile. That'll work in any situation. Requires a very little massaging to get to a point where you can be able to apply it. So rather than bombard you with a bunch of different techniques, I'm just going to show you one that should work every time, that's pretty easy to apply. Okay? This technique is called clearing fractions. So the idea here is I want to take something and multiply it by both sides of the equation so that when I'm done, all the fractions are gone. That allows me just a polynomial equation afterwards that I can solve using techniques I already am familiar with. The question becomes, okay, how do I figure out what that thing is that I need to multiply both sides of the equation by? The answer is it should be the least common multiple of all of the denominators. So right now I have 3 denominators. I have 1, x, and 1. What's the least common multiple of 1, x, and 1? Not 1. X. Because if I take 1, or I take x and I divide it by 1, that comes out. And if I take x and divide it by x, that works out, right? Least common multiple, the way you want to check is if I divide my least common multiple by the stuff, I get a whole number back, right? So I'm just going to now multiply that x to both sides. So x times x is x squared. What's x times 3 over x? 3. And then 4 times x is 4x. No more fractions. Yay! What type of equation am I left with? Specifically, starts with a Q. Quadratic. How do I solve a quadratic equation? Quadratic formula. Before I can apply that, what do I have to have, though? Yeah, it has to equal 0 specifically. So let's subtract that 4x to the other side. So to solve this quadratic equation, I can use the quadratic formula. What's the other option? Factoring. When the leading coefficient is 1, like it is here, I'm going to choose to use factoring because it's usually pretty fast and pretty easy in comparison to the quadratic formula. Everybody's cool? So to factor this, I need to find the 2 things that multiply to give me positive 3 and add to give me negative 4. X minus 1 times x minus 3. Very good. Then I can take that, each factor, set it equal to 0, and solve. So I get 1 and 3. But I'm not done. We have to check one additional thing. When I have a rational expression, the domain for these rational functions need not be all real numbers, right? But the polynomial I actually end up solving, its domain always is real number, all real numbers. So it's possible the solution to this polynomial is actually one of the numbers that's not in the domain of my rational function. So I do need to check this. The good news is this check is really easy. All I need to do is go back to my original equation and make sure that when I plug x's into the denominator, I don't end up with a 0 denominator. So if I plug 1 in for x, does that give me 0? No. If I plug 3 in for x, does that give me 0? No. So both of these answers are correct and acceptable. I am finished. let's do another example. I have just 3 more. Everybody's okay still? So far, so good? Not too bad? Okay. Next example. So I have x minus 6 over x plus 1 equals 0. What will be the least common multiple of the denominators? X plus 1. Very good. Who said that? Good job. I couldn't hear. It was all mumbly. All right. So here's the deal. When I distribute the x plus 1, I'm going to distribute it as one thing. So x times x plus 1, well, that's that. What do I get when I do x plus 1 times negative 6 over x plus 1? Negative 6. And when I multiply it to 0, I just get 0. Okay? So now I just distribute this stuff through. And hey, look, it's another quadratic equation. I know how to solve that, right? Let's factor it. What does that one factor to? Negative x minus 2 and x plus 3, right? Very good. So after I've factored it, I can set each piece equal to 0 and solve. I get 2 and negative 3. Again, if I plug either of those into the denominator, do I get 0? Nope. So they're both good. I'll continue. Everybody happy so far, so good? All right. Let's look at this one. Ooh, what do you notice that's different about this one than the previous ones we've seen? Multiple denominators. Specifically, look at that last denominator. What do you notice about that one? It's quadratic, so what might we want to do first? Factor it. How does x squared minus 4x plus 3 factor? Good. X minus 1, x minus 3. So, if I look at those denominators, what is the least common multiple of those denominators? X minus 1 times x minus 3. Excellent. Any questions on how Kate did that? Okay. So again, I'm going to treat x minus 1 times x minus 3 as one thing. When I distribute that to 2x over x minus 1, what do I get? 2x times x minus 3, right? Because the x minus 1's cancel. And then when I distribute it here, what do I get? 1 times x minus 1. Great. Or just x minus 1. Yes, absolutely. And when I distribute it here, I get just 2. So far, so good? All right, let's just multiply stuff out. Bloop, 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 bloop. I'll combine some like terms and then move everything onto one side. Everybody happy to hear? Notice that the leading coefficient is not 1. Means that I would have to do the long factoring to do this. You could elect to do that. I'm going to choose to do the quadratic formula because at this point, it's just about the same amount of work and I'm guaranteed to get an answer either way. If this thing was somehow not factorable, boy, that's a hassle to go through all that work just to find out later on that like, oh, I had used the quadratic formula anyways. So I'm just going to start there. So negative b plus or minus square root b squared minus 4ac all over 2a. So negative 5 squared is 25. Negative 4 times 2 times 3 is negative 40, or sorry, it's positive 48. Right? Yes. No. 24. Ooh, that was a big oopsie there. 25 plus 24 is 49. Square root of 49 is 7. 5 plus 7 is 12. Divided by 4 is 3. 5 minus 7 is negative 2 over 4 is negative 1/2. So far, so good. Am I done? No! We still got to check. So we got to go all the way back to the beginning. If I plug 3 into x minus 1, do I get 0? No. If I plug it into x minus 3, do I get 0? Yes. I stop. It doesn't matter if it happens once, twice, 5 times. As soon as it happens once, I'm going to cross that answer out. That is what we call an extraneous solution. Not important that you recognize that, but it probably is in the directions to check for extraneous solutions. This is what we're doing right now. If I plug negative 1/2 in, not 0, not 0, not 0, that one works. If I happen to get both answers as extraneous, I would just say there's no solution then, right? If you discard all the answers and you have no answers left, that just means there's no solution. All right, last example problem, and we're done for today. You guys have been really some great sports and actually participating more than maybe usual, which I'm pretty thrilled about. All right, what do you want to do first? Yeah, let's factor that piece. It's the same factoring problem that we've done already. What will our least common multiple be then? X minus 1 times x minus 3. Good job. So we're going to multiply that to both sides. Okay. When I distribute the x minus 1 times x minus 3 to 2.5 over x minus 3, what do I get? Good. I'm going to write it this way, though. And then when I multiply the x minus 1 times x minus 3 to 0.5 over x minus 1, what do we get? Excellent. And when I multiply it to x squared over x minus 1 times x minus 3, I get x squared. Let's distribute everything through. So that's 2.5x minus 2.5 plus 0.5x minus 1.5 equals x squared. Let's combine our like terms. So I have 3x minus 4. Move it all onto one side. I'm going to elect to move it all onto the right side so that the coefficient on x squared remains 1 instead of negative 1, because it makes the factoring easier. So multiplies to give me positive 4, adds to give me negative 3. Well, that's nothing, right? Things that multiply to give you positive 4, negative 1, negative 4. Positive 1, positive 4. Negative 2, negative 2. Positive 2, positive 2. Nothing left, right? Not factorable. What? That'll get multiplied, give you negative 4, though, not positive 4. Oh, yeah, that's the mistake I started to make right there at first. So, since it's not factorable, we have to use the quadratic formula. That's okay. So, let's see, we get 3 plus or minus. Negative 3 squared is 9. Negative 4 times 1 times 4 is 16. 9 minus 16 is negative 7. Square root of negative 7 is going to be imaginary, correct? We're not going to accept imaginary solutions here. We're going to stop right now and just say no real solutions. That's it. How do you guys feel on this? NBD, right? It's like, give me some of this solving stuff. That seemed pretty straightforward. So for your next homework set, we'll do 25 to 32. And I'm done here for today. I'm going to stop talking.